On today's episode, NASA's return to the moon accelerates. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. A gigantic space vehicle crawls slowly out of the Kennedy Space Center Vertical Assembly Building for the long ride to the launch pad. The spacecraft on top will travel to the moon and back. Now, 50 years ago, this would have been Apollo, but the scene has been repeated this week by NASA with the rollout of the vehicle for the first flight of the Artemis program. The ground infrastructure from the VAB, the crawler transporter, and Pad 39B are all legacies of the Apollo program, but the hardware for Artemis is definitely new. The launch vehicle is the Space Launch System, which when combined with the Orion spacecraft stands 322 feet tall and weighs 5.75 million pounds. The system produces 8.8 million pounds of thrust. That's 15% more than Apollo's Saturn V. The basic SLS platform will be integrated with additional upper stages and a different spacecraft and payload fairing configuration to accommodate crewed missions to the moon or deep space, as well as interplanetary robotic missions. This week's pad rollout is significant because the upcoming wet dress rehearsal will include propellant tank chill down and loading, a complete launch countdown, and a practice recycle of the countdown clock in case of a hold. Propellant drain procedures will also be tested. Now, after the wet mock, the vehicle will be carried back to the vertical assembly building where test sensors will be removed, batteries will be charged, late load cargo will be loaded, and final checkouts will be performed prior to launch. NASA has a great deal riding on the Space Launch System and the Orion spacecraft it carries. The SLS is the key, and unlike Apollo's Saturn V, the engineering of this more capable rocket includes a considerable amount of hardware proven from the Space Shuttle program. The most important is, of course, propulsion, and the 4 Aerojet Rocketdyne RS-25 core stage main engines are upgraded versions of Space Shuttle main engines. The current inventory of 16 Space Shuttle engines will be upgraded with new engine controllers, nozzle insulation, and other changes to support a 512,000-pound thrust rating. In the SLS application, they will be expended after launch, and Aerojet Rocketdyne has restarted RS-25 production to support the program and reduce unit cost. Also like the Space Shuttle, the system uses strap-on solid rocket boosters, which will provide over 75% of vehicle thrust during the first 2 minutes of powered flight. The prime contractor for SRBs, Northrop Grumman, has added a 5th propellant segment to the Space Shuttle design, as well as new avionics, a different propellant grain profile, and has eliminated the recovery parachute system, as SLS solid rockets will be expended. For the upcoming Artemis 1 mission, the upper stage will be the United Launch Alliance Interim Cryogenic Propulsion Stage, derived from Delta IV hardware and powered by another legacy liquid hydrogen oxygen motor, the RL-10. 24,750 pounds of thrust will carry the Orion spacecraft beyond the moon, then back to Earth. The Artemis program uses very different hardware from Apollo, and from an engineering perspective, the most major difference isn't in propulsion systems or propellants or guidance, but in program objectives and management. In inflation-adjusted dollars, Saturn V cost just under $50 billion, with a cost per launch of about $1.25 billion adjusted to 2021. Now, current dollar-estimated cost per launch for SLS are between $2 and $4 billion, but despite much criticized cost overruns and delays to SLS hardware development, the inflation-adjusted cost of the Space Launch System is approximately $23 billion, half the cost of Saturn V with more capability. Why? Well, extensive use of legacy technology plus advances in computer-aided simulation, design, and manufacturing combined with modern PLM and ERP systems. Plus the one factor that didn't exist in the 1960s, competition. Not from Russia, but from Elon Musk's SpaceX, where just down the beach from Pad 39B, the SpaceX Starship vehicle is undergoing test for spaceflight which, if successful, will rival the SLS for payload lift capability and may do so at a lower cost per launch. Get your popcorn. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.